My topic is related to the effect of the banana fiber on the flexure strength in concrete beam. And this is related to the sustainable.
Can you make it full screen? Make it full
If,
screen.
what?
Full
Make it
screen.
full screen.
For screen, yes.
Yeah, please.
This is related to the effect of banana fiber on the flexure strength of concrete beam, and it is related to the sustainable development goals and sustainable building material. Introduction, literature review, scope of work, experimental program, and experimental results, and finite element analysis using ANSYS, conclusion, recommendation, and suggestion. What is the problems? What we have? The introduction is related to three issues we face in our world. The first issues in our building material is the global homeless statistics, that a lot of people live in homeless building. In Asia, the percent is 42, and in Africa is 56. In others, such UK, US, Russia, is 2%. The another issues is corrosion issues that happened to the steel in the building. The third issue is related to the waste material. There is a lot of waste material in the world and related to the banana fiber. The waste every year is 2.5 billion tons. And in Egypt, in our country, is 1.7 million tons. So this is issues make us searching for using a sustainable material that we can use it instead of the synthetic material. Research is related to the banana fiber. The banana stem is harvested and the sheets are fed into machine and dried into the sun and get the banana fiber. The properties of the banana fiber, the tensile strength, it's for 15 to 914. A specific tensile strength is 392 and 77. Young modulus is 2732. Specific 20 to 24. Failure strain 1 to 3, and density is 750 to 9050. And the properties of the banana fiber increase the tensile and flexure strength, improve durability of the structure, higher resistance to lateral cracking, improve crack distribution, and reduce shrinkage of early edge of concrete. Literature review, there are three literatures. The title is Enhancing the Properties of Concrete by Using Banana Fiber. The two is the effect of the metaclonic and the banana fiber in the high strength concrete. The third, effect of the banana fiber in the compressive and flexure strength of compressed earth block. And every author of this research used the banana fiber in different parameters to know its performance in the building material. And the first one, he used 33 specimens for each cubical and cylindrical, and studies the admixture of the fly ash and silica fume and the banana fiber and the properties of the concrete. The replacement of the cement by banana fiber was 0, 5, and 10 and 15%. The conclusion is great increase in the strength. Banana fiber give more flexure strength as compared to the plain concrete, economical that compared to the waste material that we can use it replacing to the synthetic material. Adding banana fiber with 10% has a good flexure strength. The another authors, the effects of the metaclonic, he used 25 specimens of each cubical and cylindrical, studies the admixture of the metaclonic and the banana fiber with different proportion and the mechanical properties of the concrete, and he and 25 of the banana fiber with 10% and 20% and 13% metaclonic to the volume of the cement. His conclusion is and 25% is the fiber content with 10% metaclonic. The compressive strength obtained to 68 megapascal, and it is higher to the reference control. The third one, he used the banana fiber in the compressed earth block. He total is 35 green compressed earth block, 5 blocks for each 7 mix design, treated fiber with 6% with hydrosodium, and untreated fiber length is 25 to 50 millimeters. Study the compressive and flexure strength. His conclusion is 50 millimeter fibers performed better flexure and compressive strength with the when comparing with the compressed earth block. The scope of work. The scope of work is low-cost sustainable building material. We search for how to use low-cost of sustainable building material and try to develop sustainable and affordable housing. Experimental work, 14 specimens with different diameter of the beams. Beams divided into 4 groups according to the studied parameters. The first group to study the influence of the banana fiber bar in fracture strength compared with plain concrete. Second group compared the banana fiber bars with traditional steel bar. Third group to study the effect of the changing on the grade concrete 50 to 35, 45 megapascal. Fourth group to study the effect of the hybrid fiber. Numerical using ANSYS version 14. Alkyl treatment. We get the banana fiber and we make it alkyl treatment by putting in NaOH and try to set up 6% for the 2 hours in the room of the temperature. And the process of geometrical properties of the banana fiber, we came the single fiber from the India and we exposed it to the tensile strength. We make it as a bar with manual manufacturing, and we added the hardening rate not exceeded to 10%, and the diameter with different diameter of the bars, such as we see. And we make banana fiber as a bars, as steel bars, and we make treatment after we do it with NaOH. This is the testis, the properties of the banana fiber. Mean breaking strength 265 and the mean breaking elongation in 1.8. Tensile strength is 267. Young modulus as 30,000. Boston ratio is 0.3. Destiny 710. A fiber diameter 0.16, and the average is 0.14. This is the relationship is between the stress and the strain. The stress and the strain for each bars that we use in our life. The steel, this is steel. This is represents the steel bar that reach to 500 megapascal, and this is represents the banana fiber. Banana fiber reached to 267, and the ultimate is 900. And this is related to the glass fiber, and this is related to the carbon fiber. The glass fiber with 750 and the carbon fiber with 1,700. So When we can explain from this that the banana fiber has a high tensile strength, and we can compare it with the steel traditional bars. The first, compare it with plain concrete. We make a beam and compare it. We put in the beam banana fiber bar and compare it with the plain concrete. The second, compare it with the steel reinforcement as we use it in our traditional building material. And third grade of the concrete, four, hybrid material, five, compare the experimental with the analysis, barometric study, cost. We make a beam, the chart as we see, and we put in the beam instead to the steel traditional bar, we put the banana fiber bars in it. This is the beam, plain concrete, such as this, without any steel, without any banana bars, and steel. We put steel with diameter 8 millimeters, and this is banana fiber bars with diameter 12, and this is steel bar with diameter 12. This is banana with diameter 14, with steel bar with 14, and so on. But we used the reinforcement, plain concrete, mild steel, banana bars, and steel bars, banana bars, steel bars, and the grade of the concrete is not fixed in some of the specimen, but in the BFB banana fiber bar with grade 35 and the banana fiber bars with grade 45 megapascal. And this is glass fiber bars, and this is hybrid fiber bar. The glass fiber bar with grade 25 and the hybrid with grade 25, and this is 25. What about 25? What about hybrid material? It's related to composite material, glass and banana bars. This is the beams, and this is the supports. This is banana fiber bars. This is banana fiber bars with different diameter. This is during specimen for work with steel cage surface and level up to the smooth surface. The specimen form work, burning and finishing. Specimen 1. Specimen 1, brittle failure due to it's plain concrete. Specimen 2, when we put the banana fiber bars, when we put specimen 2 banana fiber bar, it's a flexure, as it's called flexure failure. And 3, it's happen the same. The third, the beam 8, it's called shear failure due to its diagonal shear cracks due to the load, because it had a glass fiber. And this is the hybrid material, that composite material, that glass fiber and banana fiber are also the cracks is shear failure. This is beam 1, beam 2, beam 1, beam 2, beam 3 to beam 10 without steel, with steel, banana fiber bar, steel, banana fiber bar with different diameter. The load, the first crack, and the maximum loading crack, and failure load, and the behavior of that load. We can show from this figure that the indicate that the brittle failure mode. However, there are assigned matrix adhering of the fiber indicating a descent bond within the fiber matrix surface. This causes brittle failure within the fiber surface bonding influence interlaminar strength and the interlaminar shear strength, and also interlaminar tensile strength. This is the load deflection curve for each specimen. And this is the load deflection for the plain concrete and the banana fiber. We can show that when we use the banana fiber, it increases than the plain concrete for specimen beam 1, beam 2, beam 3, beam 4. This is the indication that all of beams, this is the bearing concrete without any traditional steel bar, without any reinforcement. And this is the, when we put the banana fiber bar as a reinforcement, it increases the strength with 25%. The first class, failure load, rupture for each beam. The result revealed that the width of the crack and deflection at the midspan are significantly reduced by increment of the reinforcement ratio. The ultimate load enhanced with 5% to 10% in reinforcing increase 0.73 to 1.66. The banana bars, when used, the banana fiber bar, the tensile strength is 265 and the mild steel is 240. This is the beams and the type of the failure for each beam. And this is also beam and the types of the failure for the beam. We can show that when we compare the banana fiber bars with the steel bars, that the banana fiber can carry 60% from the mild steel. But when we compared with the high tensile steel, it can carry 30% from it. And this is the banana fiber, and this is the high tensile steel, banana fiber, high tensile steel. When we use different grade of concrete, the different grade would have a big influence in the behavior of the concrete, such as it's 25, 27, 28. For 25 megapascal, 35 megapascal, 45 megapascal. The hybrid fiber is related to the combined fiber or composite material. A hybrid fiber is have a two glass and have a banana fiber. When we use it, this is the glass fiber and this is the hybrid fiber. The hybrid fiber carry 75% from the glass fiber. When we make a comparison that the required design is 32, the banana fiber give us 28 and the experimental give us 42, and ANSYS program give us 43 megapascal. Thus the required design is 32, the banana fiber is appropriate to the required design and not far from the experimental. This is the finite element analysis that we use. We try to use the ANSYS 14 program to study this parameters, beam 1, beam 2, beam 3 to beam 7, and this is B and T, the width and the depth and the total depth and the depth of the beam, and the shear span to depth ratio, the grade of the concrete, longitudinal bar, AS and AS dash with stirrups. And bearing, this is bearing load, and this is the concrete, this is the steel bars and a banana fiber bars. Group A, group 1, group 2. We can show from this is the ANSYS program. This is the failure is such as the experimental program that add fracture failure. And we compare the results with the result of the ANSYS program. So that is appreciate the comparing the experimental and numerical good agreement for the beam 2, beam 1, beam 2, beam 3. This is the experimental and this is ANSYS for each beam. A lightweight, this is diameter and the length of each bars and the number of bars in 4 ton and the weight of the steel bars or number of bars of banana fiber. The banana fiber have a light weight, so we can the ton for banana fiber give more than that traditional steel bars. So that make the cost is reduced 50% from the traditional steel bars. A banana fiber, the cost of one bar is less than the cost of the steel bar with 50%. Conclusion: based on experimental program and numerical, it is important to convert the waste material to came from the banana fiber to a new source to use in small construction building or temporary building. And banana fiber are a waste product of banana cultivation, therefore there are no any additional cost. It has economical impact factor when used in construction purpose. It reduces the cost with 50% when comparing traditional steel bars. Banana fiber reinforcing for concrete beams give more flexural strength compared to the plain concrete. Banana fiber bars reinforcement contribute with 60% of the flexure strength when we compare this with the traditional steel bars. The concrete strengths have a small impact in the ultimate load at failure. The predicted numerical results using ANSYS program, a good agreement with the experiment results. The simulated cracking pattern and the failure modes are nearly similar to the testing results from all beam. The average ratio between the measured load and the predicted load 0.98, and the average ratio between the numerical and experimental ultimate deflection 0.86. Recommendations: it can recommend to use the banana fiber in structural element due to the low cost and eco-friendly compared to the other synthetic material. Banana fiber bars can use in the economical building because urgent need to develop sustainable and affordable housing. Banana fiber bar can use instead using a steel bar to reduce the corrosion that happens to the steel bar. It suggests that the hybrid epoxy composite can be used as alternative material for synthetic fiber reinforcing composite material. Suggestion for future study the behavior of the banana fiber in different parameters. Thank you. Thank you so much.
Thank you, Professor Albert. So that was a wonderful presentation. So I'll leave some time here. If anyone have any questions or comments, you can please go ahead and ask Professor Ember.
Can I ask a question?
Yeah, Professor Wilfred.
Yes, so it was a very interesting talk and very beneficial for all the stakeholders.
Thank you.
So I want to ask, do you have already some long-term experience about the banana fibers? I mean, building want to stand 30 or 50 or 100 years, and is there any degradation of the banana fibers during long term?
This is banana fiber. We know that it's natural material. So the natural material is biodegradable material. So we can make a lot of treatment to make it using in our construction. So when I conclude it, I make it using waste material in a small construction building or temporary building. That is for a small period, not for a long time, because it's biodegradable material. So we can control for this biodegradable and how to control the biodegradable. Is there any treatment for this or no? It's related to the physical or chemical scientists. But for me, I can't control this. So my material as a waste material, I controlled it to use in the temporary building, such as the temporary building in any in the project, in any for period, not for a long time.
I see.
Yes.
I mean, with some proper chemical treatment, probably the lifetime will be much longer, I guess. No? So anyway, good luck for your research. Thank you very much.
Thank you. Thank you, Professor. Thank you.
Thank you, Professor Alfred. Yeah, if any others have any questions or comments, please go ahead and ask. If nobody have any questions, that concludes.
I might have one, just a curiosity.
Yeah,
Thanks a lot
Yes,
for the
Professor.
interesting topic. I'm not an expert, so maybe my questions could sound, let's say, a bit naive. So I apologize in advance, but it's just a curiosity. First, I was thinking, since you embed these banana fibers inside, let's say, the beams of the building, I was wondering whether you have investigated the flammability of this material and if it can be of any concern in the use of the building, in the safety, let's say, from the safety point of view. A second question is, I'm very curious of how the banana fiber and if the banana fiber, microscopically speaking, binds to the concrete. How do they interact microscopically? Have you ever
Yes.
investigated?
Yes, the first question that related to the banana fiber when used, there are two type of the material, synthetic material and the natural material. Synthetic material we use as carbon and the glass fiber, and some countries use carbon and the glass fiber bars as a bars in a lot of projects. So a lot of interested topics that go in the way to the plant fiber or the natural fiber to make it instead of the synthetic material because it's eco-friendly and have low cost when comparing with another material that using in the building material. And in another way, we study the impact of the cost. A lot of building material have a high cost when comparing to the living of anyone, of any person in the life. So we try to use a waste material that come from the waste, have a no cost, have a no didn't want to clever labor or any such as this, so we can use it. We have a lot of issues when we use it, such as that professor asked me about this biodegradable material. Yes, it's biodegradable, and it's just we try to make a treatment for this biodegradable to use for a long time and to make the cost of the building material very, very low, not very, very high, because the main that effect in the cost of the material is the steel bars. The cost of the steel is very high, so the building material is the building construction is very high. But when we instead it by another material such as waste material have the same tensile strength, have the same properties of the steel bars, we can solve a lot of problem in our world. And the second is it's eco-friendly. When if the waste material burn it will expose and it will expose to the environment to CO2 that make a damage and make a lot of diseases in our world. That carbon dioxide, when we burn the waste material, it creates a carbon dioxide with a high percent. So carbon dioxide make a lot of diseases, make a lot of global warming, make a lot of issues, especially to the environment. So it is benefit to use this waste material. This is the first. The second, how the banana fiber microscopic. There are a lot of researchers study this banana fiber in microscopic for concrete. A lot of researchers do this, and I have a lot of paper in my work related to this, and the bond material, the bond strength between the concrete and the banana fiber, the cohesion between the concrete and the banana fiber, and the contact. The contact of the surface between the surface of the banana and the surface of the concrete. A lot of research included this.
Okay. Yeah. Okay. Thanks.
Thank you very much.